Yeah, so welcome back, guys. This is Madhav PVL, and now today we are going to discuss about the tutorial continuation computer networks and security. And please subscribe to Works of the College. Yeah, now let's start the thing. So now let us see what is meant by an internet architecture. So what is internet? Internet is something which is used for many purposes, but now in this subject, in this particular topic, we are going to discuss only about the data exchange or message exchanges with the help of internet in between two systems. So with the help of internet, the exchanging of the data in between two systems will be discussed in this particular internet architecture. So it doesn't have any strict layering. So it doesn't have the defined transport layers, so it is having a free bypass. So we can just say like whatever route it may take, it can reach at whatever route it is taking. So it can reach the message of one system to another system with whatever route it is decided. So it is an hourglass shape, wide at top, narrow in the middle, and wide at bottom. So what is this thing? So this is basically, we can just say like the data entering into that particular internet architecture, the data can be entered in any way. So they can just put a lump sum amount of data, whereas in the middle, that where the data is getting transferred, the transfer control protocol layer. So this is this layer, the middle one. The transfer control protocol layer will be a bit narrow, because there some of the decisions were made, like in which way it need to go, in which way this need to go, in which amplifier it does need to go, and those all things will be discussed in this middle layer. So this will be in a narrow shape, and then whereas it will be wide at bottom, because there will be n number of amplifiers in this internet architecture, so it can just transfer the data in whatever way it is required. So internet architecture consists of mainly of three layers, that is application layer, transfer control protocol layer, and then internet protocol layer. So application layer in the sense, the thing, the layer in which we just consider the data, or we will just give the output. The way the layer in which we just take the input and give the output is an application layer, whereas a transfer control protocol is something which we can just say like there are n number of amplifiers, or there are n number of protocols, whereas the transfer control protocol will just decide a particular application to choose to just switch in between these amplifiers, to just choose a path for transferring of a data, whereas internet protocol is something which we can just say like the way in which the data gets transferred from one system to another system with the help of this internet, whereas network application interface. So this interface is exported by the network. This is exported by the network. Since most network protocols are implemented in nearly all computer systems implement their network protocol as a part of OS. So what is this thing? So basically, to transfer some data in between two systems with the help of internet, it requires some prerequisites. So those prerequisites are something like so they are all a part of the operating system. So since most network protocols are implemented in all computer systems, these protocols must be a part of an operating system. So the protocols are transmission control protocol or internet protocol. So we will just discuss about these things. So these both are forming a stack structure, whereas these both have differences in between them in the place of this internet protocol layer. In the place of this internet protocol layer, they both have differences. Like application layer is something like the way in which the data gets transferred, whereas transport control protocol, these all things will be the same in this both layers, whereas in this internetwork, so in this internetwork doesn't have any proper way of just transferring the data, whereas in this internet protocol layer, they will have two types of arrangement protocols. They are internet control message protocol, whereas address resolution protocol. So internet control message protocol, so this is something like the message will be divided into chunks, right? So that stream of packets will be sent through some particular ways. That way will be decided by this internet control message protocol, whereas address resolution is something like if the data is transferring through this internet, then there should be some addresses or identifiers, right? So those all things will be decided by this address resolution protocol. So in the last one is the same for this both the network interface and hardware network interface. So the network interface is something like Google Chrome or Mozilla Firefox or Internet Explorer and Edge. These all things are the network interfaces. So they use internet to transfer the data in between two systems. And then application layer. So what is application layer? This is for communication. It is an user process with different hosts. It is defined by port numbers and sockets. Whereas transport layer is something like an end-to-end data transfer. Multiple applications are supported. Another transport layer is user datagram protocol. It provides connectionless, unreliable. Internetworking layer. So internetworking layer is something like the functions which were implemented in this networking layer. This all are done in this internetworking layer. Routing function to deliver transmitted messages. All these things are done in this internetworking layer. So network interface layer, it consists of some underlying networks and connection paths. Now if we see this application layer 2, domain name system. So what is domain name system? As internet is something which we can say like it's a global interface. So for a global interface, to avoid some confusions, we will just use this DNS. So it is a global database system for internet addressing. So DNS servers will just transfer those domain names into some IP addresses. IP addresses, we know them, right? 192.163.19.18, something like that. So servers will just transfer the domain name. So if I just say something like madhavpvl.edu.tech, so the whole thing will be just converted into some IP address. So the IP address will be unique for every domain, right? So IP address can't be duplicated. So that will be unique for each thing. So every domain name will be just converted into this IP address. Whereas domain names and labels, they form some hierarchical layer. So there will be something like, so here if we just see challenges.atc.fnda.edu. So now if we just see, the root will be something which is which we can just say like, so if we just consider this link, so if the link is belonging to hacker rank, so if this link is belonging to the hacker rank, let us just consider. So if we just consider this, the hacker rank is the root. So root is a hacker rank. So from hacker rank, it will just get into this label which is known as edu. From edu it will just get into this fnda. From fnda it will just get into this atc, and finally it will just get into the challenger. So if the main root is an hacker rank, so from the hacker rank it is going to define bit by bit, label by label, it will just get into one to the another. We can just say like, if we just get into one of a big building, so if we just need to get into our room, then we need to just get through the entrance. After entrance we need to just get into the second floor, and after second floor we need to just get into the second left row, and from the second left row we need to just get into the first room, that is finally the final label. So we need to just move a bit by bit, so one after another we need to just move like this, so it will just maintain some order. So domain names are arranged in a hierarchical way. So fully qualified domain name. So fully qualified domain name, if the domain name ends with a dot, so here we can just see, so this is a dot. So if it ends with a dot which doesn't have any further labels, so fully qualified domain name is something like which ends with a dot, so which doesn't have any further labels. So here the challenger is something which is last. So here we can just see, so the root server is something like an hacker rank. So So HackerRank will also have some remaining factors like it will just have some Java challenges, it will have some C challenges, it will have some Python challenges or another language challenges or whatever it is. So in the Java challenge we will also have question number 1 and question number 2. So it is something like it is just it is having some order. So in the main root it will just divide it into some another subroots, and from that roots it will just give some another labels. So here we are just defining them in this way. So from root there will be so this is a root. So root, from root these are zones. So from these zones here they will have some domains. From the zones, domains are mentioned here. So in this way the whole data will be, or the whole representation of that particular internet service will be in this way. The root service are represented in this way. So zone, so domains are broken into zones which have individual DNS servers. It represents the entire set of names or machines. So domains are broken into zones which have individual DNS servers. So these will have individual DNS servers, individual IP addresses. So it doesn't depend upon each other. So they will have some individual names, individual servers, individual IP addresses. Each domain can contain 2 or more DNS servers, primary and secondary zones. So primary zone contains the master copy of a data for the zone. Secondary zone receives the copies from primary zone through zone transfer. So here we can just consider like from this edu server, one second. So edu server is something which we can just consider like a primary zone. So it will just contain the whole data from that primary zone. Here the data will just get exchanged from one another. So that is meant by this primary zone and secondary zone. Receives copy from the primary zone through zone transfer. And now generic domain, proper index, country domain, proper index, inverse domain, index to names or IP addresses to names. So here the domains are of different types. Generic domain is something like a proper index, whereas country domain is something like if it ends with last with IN, COM, US, NZ. So it represents some country names, whereas inverse domain is something like the IP addresses to names or names to IP addresses. Whereas name resolution process, it is a commonly used server in Berkeley internal name domain, runs under Unix. So name resolution process. So name resolution process is something like which is used for the purpose of converting a purely qualified domain into some IP address. So with the help of this name resolution process, that which runs under the Unix operating system, will just convert the domain name into some IP addresses using the command nslookup. So with the help of this nslookup command, it will just convert the data in whatever way it is required. So this is the thing. So if you just see this DNS full resolver, so if once the user program is given here, like to just convert some name, so user query will be sent into this full resolver. So from full resolver, it will just give some query to the name server. So from name server, it will just get into this database and check for the name which is not present in the database, and then again it will just check into this foreign name server, and then it will just check for the data whether the data is not present in that particular database, and it will just create some unique name, unique IP address with the help of this cache memory, and it will just give back the response to the full resolver, and then it will just get back to this user program as a response. So in this way, these caches are used for the purpose of converting a domain name into some IP address. So domain name stub resolver. So stub resolver is something like which is used even without a cache memory. So even without a cache memory, we will just send directly queries to the name server, and then we will just convert them into the IP address. So it is implemented by two library routines, that is get host by name and get host by address. So these two are the things which we can just use for sending queries directly to the server even without the cache memory. So DNS resource record. So resource record is something like it is a mapping between the domain names and network objects. So this is a name server record which contains the details of the primary name servers for the zone. So all the primary name servers of the zone will be mentioned in this DNS resource records.